topic today is everything you wanted to know but were afraid to ask about standards. And I have a bunch of acronyms, and this is not the end of the list, but we'll try to cover something of the order of IEEE, ANSI, IEC, UL, NEMA, and whatever else you want to know. My name is Mietek Glinkowski, if you can pronounce it. Obviously, you'll judge from my accent, I'm not Irish. I was born in Poland originally, but I've been in this country for something close to 30 years now. I did my doctorate degree at the Rensselaer Polytechnic Institute, good old school in upstate New York. I'm now Director of Technology at ABB. I'm located in Raleigh, North Carolina. And now this is my office, but I'm not there most of the time. And with that, I want to start the technical part of it, and I call this Standards 101. For some of you, this is probably what you already know or live by, like yourself, but some others probably are sometimes confused between what is UL or what is IEEE, and we hear C37, and there's ANSI, and there's IEC, and this is NEMA, and so what is it, and where does it fit? And then, you know, when you have the equipment that has this label with the specific standard mentioned there, what does it mean from the performance point of view, or even from the legal or liability point of view in case you have a problem? So I'll try to address these aspects from a very broad perspective. I'll try not to go into technical details of any specific standards because we just don't have time of it, but I want to hopefully explain to you how all these different organizations work and what are the synergies or discrepencies between these different organizations, as well as a standard development process, because standards are developing every day, all the time. So what we try to cover today is a standard process and standard developing organizations. What we try to cover is particularly relevant to the power industry and as well as the automation industries. And we try to cover international as well as national standards and how this impact the user, the third party, and so on. But what we'll not cover, as I mentioned before, is some local regulations or city or states or some customer-specific requirements. If you're writing a spec, you probably have something on top of whatever the standard defines. So the two major parts of the presentation, again, my background is in the United States, so obviously the focus is going to be on standards that are applicable to United States. Let's make it maybe North America if we add CSA and some of these standards in Mexico. And we'll touch a little bit of the international standards, primarily to show you how similar or how different they are. So the world is divided into two parts. If you simplify this map, if you look on the left-hand side in Americas, you will see what I call an ANSI world, or maybe UL, or maybe CSA, but it's sort of a one continent, or one cluster, or one region in the world, and most of the rest of the world is IEC. Although there are exceptions, you go to island of Taiwan and you will see that there's ANSI equipment, or you go to Japan, where I was there last week, in fact, and some of the products there, although they're IEC, they sort of look like ANSI. So there is, it's not a clear cut, but for a simplicity point of view, you can say there's an ANSI IEEE world on one side, and there's an IEC on the other. So from the United States, and this is something that will also have some legal implication, and I'll tell you a little bit more about this in a second, standards are actually voluntary. Most people don't realize it. They're not mandatory, they're voluntary, unless they become part of the law. And I'll tell you a little bit about the law in the United States at least. So you cannot say that you violated the law IEEE 1584 on arc flash, but what you say that your equipment did not comply with a given standard like IEEE C37.20.7. So unless it becomes a law specifically, standards are voluntary. If I, as a manufacturer, decide to build a piece or design a piece of equipment that doesn't comply with any standard, that's fine with me. I'm not breaking a law. And if you, as a user, decide that you're interested in this equipment, I'm going to buy it from you. I say, fine. Does it comply with C3706? No, but I'm okay with it. I can live with this. It complies with IC 62-71-100. That's fine. It's between you and me if we make a transaction. It does not prevent me from doing commerce in whatever equipment I design. Although the reality is slightly different, if you don't comply with the standard, nobody wants to buy it. But this is just a decision based on commerce, what I want or what I don't want to buy. It's not the law. So the law, at least in the United States, is that my favorite Code of Federal Regulations, or CFR. I don't know if you ever read some of this, but these are beautiful Bibles to read. I mean, if you have sleepless nights, I mean, it will really put you to sleep. This is worse than reading the homeowner insurance papers or you know, your bank statement for your credit card with all these small prints. But anyway, the Code of Federal Regulation is a law, whether you like it or not. Maybe it's written by the lawyers for the lawyers, but that's how they get you. Both on the user side or the manufacturer side or whoever is involved, and consultant as well, if you don't comply whatever is written in any of these CFR titles, you're dead. And you know, I think Enrique Santacana mentioned something about there's a lawyer behind every tree or something like this. Well, in the US it's true. There's a lot of lawyers that are just waiting for some cases. Huh? So the CFR is the codification of all the different rules and stuff like that. CFR is divided into 50 titles. So boy, it's a big stuff. Represent different areas of federal regulations. And obviously we're not going to details in any of them. But for example, Title 29 is Department of Labor. And they are interested in safe environment and safe equipment for the workers to work in. Or whoever, and it could be the public as well. But safety is the beginning of what the CFR, or at least Department of Labor, is after. So from the federal regulations point of view, that's where it starts. Title 29 is divided into what they call parts. And these parts are labeled differently, 1910, 1911, 1952. Somebody asked me if this is like a year when it was actually written. No, it's not. It's not written in 1910. The OSHA, which was part of Department of Labor, did not even exist back then. So these numbers don't correspond to years. These are what they call parts. And in part 1910 of Title 29, there is general industry, which has a lot of references to what we're doing in the power industry. And you'll see a little bit of this later on. But there are other parts, and this is just a sample listing. This is not the complete listing, from marine, record keeping, agriculture, estate plans, and so on. So, and the parts, in turn, are divided into subparts. So this is not the end of it. So the 29 CFR 1910 has a subpart A through subpart Z. And for example, subpart S, there's a very important for the power industry in terms of, again, safety in power equipment. So each of these subparts of the parts, they also now has many articles within it. So there's another subdivision. So when you look at some of the pieces of legislation, you will see, boy, it's 29 CFR 1910 A, Article 310-5-7-27. I mean, it's a very long thing to decipher, but actually this is what, you know, these parts of the documents, that's how it's structured. OSHA, and obviously everyone knows that, the Occupational Safety and Health Administration was actually established in 1970 by the OSH Act. And again, because of the Department of Labor, their beginning, their fundamental assumption is to look for the safety of the workplace. And that obviously dictates in power systems what we do with wiring, what we do with equipment, what we do with short circuit current, what we do with providing grounding or isolation and so on. Again, as I said, most relevant to electric power industry is part 1910. That's where you should start. It's sort of general industry. So for example, the subpart S, you remember it's from A to Z, all the different subparts. Subpart S addresses electrical safety requirements that are necessary for practical safeguarding of employees in their workplaces. And for example, if you drill down to just one, I cut and paste out of the whole document just one little title of one of the articles, 29 CFR 1910.304 F1 lower Roman numerals 7 and 8 is overcurrent protection of 600 volts minimal or less. And it goes through, you know, details after detail after detail. So it is down to the minutiae, it is down to the very detailed level what the law requires or what the law spells out, we do. If it is a law, then you have to now comply, whatever it's written there. If it's only in standard, but it's not in the law, you don't have to comply. It's voluntary. However, OSHA frequently makes references to standards like NFPA, like ANSI, or like IEEE, or UL, or ASTM, and so forth. So you have to be aware of both sides where the standards are and what parts or its entirety of this is coded or spelled out in the CFR. And again, for the legal reasons, and I've been involved in legal processes involving power industry on many different sides of this, again, the law is what the lawyers are after. They can get you in standards if they want to, but the law is what they can really nail down. So I want to go a little bit into detail. So we started with the legal requirements, and now we want to go into what the ANSI is. Again, we heard it so many times in different contexts. And for example, if you look at this OSHA part S301399, the references of OSHA goes to ANSI IEEE C2, which is a National Electric Safety Code. It references NFPA 70. It references NFPA 70E, with this safety requirement, for grounding, for arc flash, and PPE equipment, and so forth. So now this is written into CFR. There's another example, and again, you just read it. I don't want to go through the details because this is just a sample of what you might find. But in the note, it says, this is a grounding system to be used on the energized electronic equipment, ASTM F855 1990 edition. Now, your grounding or temporary grounding on de-energized electrical lines based on CFR have to comply with this. And I've been involved in cases regarding this. And you get, because now it's in CFR, this is a law. And in the United States, you go to court, and 12 people will sit there and listen to both arguments and decide who is guilty or not.
Can you comply with some later revisions, or you have to comply with the 1990 revisions?
That is a good question. You have to check. I copied this based on the CFR that I have in my computer, which maybe it's not the latest revision. But the good point is to always go to the internet, and because it's government, it's free, and you can get any CFR at any time. I think any, at least the ones that electric power, I know I can get any because I have it on my computer on the web. It's one of the GAF pages. I don't remember the URL address, but if you just Google CFR Title 29, it gives you the slew of different table of content of all the different documents, and you click on part 1910, and it'll gives you to all the subparts, and you can get there and verify if what I tell you, again, this is an example, but verify what I tell you, what the most recent revision of CFR is. If they reference whatever this is, then if you comply with this, that's fine. However, again, if you in the court of law, and just speaking from my experience, lawyers can argue if indeed there was a newer standard that did not get to CFR yet, but it is already on the street or published, then they say, why didn't comply with the newer standard, or why didn't the user do this? Because he was required to put the temporary ground with the bitter clamp. Then it becomes how effective you are to the 12 jurors who are sitting on that bench. But it's not a clear cut. It's an argument to say, well, the industry moved forward, so indeed you should be complying better. But the argument could be, well, we haven't done it yet. We will do this in 2 or 3 years. It's a voluntary standard, but it takes a few years to actually retrofit my power plant or my chemical plant or whatever power system you have. But the law is a law. Then there's no question about this. Either you violate it or not. Some of the other ANSI rules. Well, ANSI by itself is by membership. And this membership comprises of government agencies, other organizations, corporations, academic, international bodies, and individuals. ANSI by itself does not really develop anything. ANSI is an office in New York City somewhere, and they really don't do much except the bureaucracy, I call it. They actually don't develop standards. They only certify or approve that whatever standard one of the members is going to develop, then it becomes an ANSI or American National Standard. And what they do, again, in certifying that this will be an ANSI standard, is spelled out in some of these bullets. The process involves consensus. This is not an edict. Somebody up there in the government says, you shall do this or whatever. No, this is actually membership, sort of democratic process where we have to have these organizations agree to whatever the standard is going to say. There is a public review. You and me can publicly comment on whatever the new standard or proposals for new documents are. If I don't like it, or if my organization, ABB, looks at this and says, oh, this standard is going to kill our business in the United States, we have the right to the review and comment on all these proposed new standards or documents. These comments have to be responded to. They cannot be ignored. Let's say if I have a comment to a standard from an Acoustic Society of America, and say, I don't like their noise levels on transformers in New York City, or whatever it might be, and I have the public comment, I submit this within the time frame it is allowed, they have to respond to me. They do not have to agree with me, but at least they have to address my concerns in one fashion or the other. But again, goes back to consensus. So, and finally, they have to incorporate the submitted changes that meet the same consensus requirement. Again, goes back, it's a loop process. You have to go back until you reach that consensus where all the organizations involved finally say, yeah, it's good to go. And finally, if I really didn't like, and I feel as an ABB or as IEEE member or whoever else, that they did not address, whoever wrote the draft or whoever proposal, did not address my comments, I have a right to appeal. Very democratic process. But there's a price to pay for the democracy, which is speed or timing. This is just a graphics, but it shows just few members of the ANSI organization. There is, I think, over 100 of them altogether. I didn't even count them all, but there's many, many of them. And again, you can go to ANSI.org and find out all the memberships. And it goes from Acoustic Society of America to Air Conditioning Contractors of America. I love this one, American Society of Baking. Or there is a society that builds fences, American Fence Association. I mean, fishing people, whoever. They all are members of ANSI, and in their respective categories, they have to declare what their expertise area is, but within their respective category, they are allowed to write standards that become ANSI standards. So it's not only power industry or automation industry. I mean, you can do it in baking, if you will. No problem. Within their own scope of interest, if you will. More relevant to the power industry, you see, and that you probably recognize most of these logos, there is NFPA, I mean the famous NFPA 70N 70E that we have to live by on ARC Flash. There's ASTM, there's IEEE, but there's even IEEE National Electric Safety Code, which is a separate membership. It's sort of funny, IEEE, it does more than just one membership of ANSI. But there's a National Electrical Contractors Association. There's NETA, testing people. NEMA is there, Green Building Initiative, and AWEA, the wind people, American Wind Energy Association. NERC is there, the government organization. So, and many more. This is obviously not a full list. But again, under the umbrella of ANSI, there's many organizations that can develop standards. And if you just look at these logos, you can now imagine a potential for conflicts if NETA, for example, starts developing a standard for testing circuit breakers, That's just sort of my background here that I can speak of switchgear. And IEEE has the whole slew of circuit breaker standards already in their portfolio. But they're both declaring that we are expert in circuit breakers. And we had conflict like this before. And I'm sure we'll still have this in the future. There is a little bit of a coordination that we're trying to do, at least from the IEEE side, that is where I'm sitting at. But AWEA might decide that we have to have a special requirement for the power systems in wind turbines. And if they decided to develop the standard and they write the proposal, they write the draft document, they assemble the working group, and they finally, they might ballot this and they submit this to ANSI. Well, we might find out late in the process, if they don't coordinate with IEEE, that they are actually conflicting with whatever else is on the street already. This is why we have to go through the consensus process. And it happened before. I mean, and it will happen again, I'm sure. So again, ANSI is an umbrella, voluntary organization. There is a potential for conflict. You just cannot avoid it because it's a democratic process. But at the same time, the ANSI has unsurpassed reputation and trust within many industries on both users, manufacturers, consultants, academia, and so on. I mean, ANSI is it, at least for the United States. I mean, people say, well, if it's ANSI, it must be good, must be that the whole industry is for it. And again, I'll give you some examples of some of the conflicts or some of the standards. Another example I gave you, NEMA used to have a lot of switchgear standards. And a few years ago, maybe 5, 6, maybe somewhere, they decided, well, there's too much work to actually maintain these standards, go through the cycles. They actually gave some of this to the switchgear committee. Like C3706 was a NEMA standard. They still keep 54 and others, but they say, well, no, you guys do it. You do 04, 09, and these are circuit breaker standard. 06 is circuit breaker rating standard. Why do we have two different organizations doing basically the same thing for rating or for testing of structures? So they say, you have it. So it happens this way that people just become more rational and they say, well, one organization is maybe better suited to doing this than two organizations in parallel. IEEE. And again, that's another acronym. You've seen it ad nauseum, I think. This is an association that serves at least 3 primary functions. And I want to say 3 because later on when we touch on IEC part of this, then you will see the difference. In IEEE, besides standards, which is an important part of it, and we quote IEEE standards all the time, I think mission of IEEE is also publications, technical conferences, technical events, educational, professional development of members, and so forth. I mean, there's an IEEE general meeting every summer. This summer is in San Diego, I think. I forgot about it. I mean, every summer we meet in IEEE for general meeting in Power Energy Society now, where we have basically all the publication, all the education, all the professional, all the paper, and so on. We don't do much standards. But, for example, in Switchgear Committee, we meet separately from the general meeting just to focus on standards because it's another body of work that we just cannot do this in the same time during the period of 1 week or 5 days. So if I take only the 1/3 of the IEEE, the standard development process, then I look at the IEEE and say, well, total of IEEE, I think 400,000 members globally, or 500,000, something like this. I mean, the largest professional organization in the world, IEEE, the largest professional organization in the world. It's divided into 38 societies. And out of the 38, I've just listed a few of them. Obviously, closest to my heart is Power and Energy Society, or PES. It used to be Power Engineering, thank you, Power Engineering Society, but we changed to Energy because it was more sexy. We wanted to attract more younger audience from the high schools or colleges, whatever. So I say, well, energy and power is okay, but it's sort of like dirty, old-fashioned switches and oils and transformers, and we don't like this. Energy is more like wind and maybe photovoltaic, so it's sort of like that. So it was still E, so thanks God E was E. So we switched one E for another, and now it's Power and Energy Society. And I'm a member of that society as well. But many of you are members of Industrial Applications Society, and probably some of you at least heard of Power Electronics Society, that we do more and more of this. Industrial Electronics, Dielectric Society, Computer Society. The largest part of the IEEE is Computer Society. I mean, all these freaks in 802.11 and all the other computer standards, obviously, there's the largest part of it. But Power and Energy Society is probably if not first, the second most active in terms of standard development, because our industry is so standardized for good reasons, safety, operability, reliability of the system they have to deliver. Not all societies participate in standard development. There are some others that just do the educational part, or they do publications, and others. Power and energy, we are involved in both. So again, if I drill down through the whole process in Power and Energy Society, we are divided in turn into 36 committees. 36 committees. And in one of these committees, I sit in, and some of these committees are standard developing. That's where we actually write standard. There are a group of people sitting there in writing or deciding what the ratings are, what the standards are, what the requirements are, what the guide for applications are, and so on. But there are other technical committees, they don't do any standard development, and some other coordinating committees and standing committees, like for publications or for education and so on. The most important for us, again, from standard point of view, is the 23 committees that they actually do the standard work. So on the standard work, again, there's just a short list of, or fraction of the list of what these committees are. And the switchgear is the closest to my heart, but I'm sure that you've involved in electrical machinery committee, or insulated conductor committee, or station battery committee, or substation committee, or transformer committee, big deal. Very active in transformers, writing standard for transformers, mainly C57 group of standards. So in switchgear committee, again, I'm drilling down again at another level. You see how many layers it is. So IEEE is IEEE, but it's a huge organization and a number of different kind of work that we do. But if you go and drill into one particular one, which is closer to my heart, is the switchgear committee, where we have 100 plus or so documents. If you, in the old days, before the CDs were invented, or the USB drives, we used to publish this in a book. So it was like a telephone book, so it was good to sit on it, almost like the Yellow Pages. It's about 1,000 pages plus that every maybe 2 years or 3 years we have to buy it again because standards were revised or modified and so on. So when you want to write the spec, you have to make sure you write the spec based on the active or the current standard. So that was a big telephone book, and I still keep one, I think, from 1999 or something like that, just for historical reasons. But now these things you can download. They're all available through IEEE. And if you're not an IEEE member, I think you have to join the IEEE member. And then if you are an IEEE member, you then can buy, or your company can buy, subscription to IEEE Explore. So IEEExplore.org. And through that, you have access to standards. And if you go there, and it's a very easy search engine, you go there, you can see, for example, switchgear committee standards, and you will see most of these standards that we have the acronym, or the beginning of the code of the standard is C37, although we have some other standards which do not have C37 code, they just start with IEEE. But this is historical reason. Today, there's no significance between what these numbers are. It's sort of it used to be just number that was assigned on the basis what the next document was, and then it was changed to IEEE, some was IEEE, but not recognized by ANSI. So some of the standards became only IEEE, but ANSI did not recognize because it didn't go through ANSI process. So it was just historical reason that the standards sort of have two different nomenclature in terms of the codes. But if you look at the titles, I think most of them are self-explanatory. And even if the title is not self-explanatory, you look at the first active page, if you will, where there's a scope, which is 2 or 3 sentences of what this standard covers exactly, or what it doesn't cover. Within the switchgear committee, and we meet twice a year in our particular case, there are specific subcommittees. So in switchgear, for example, I think we have 5 or 6 subcommittees. I moved through that. There's one specific for high voltage circuit breakers. They only do these standards, and there's about maybe 10 or 12 of them. There is what we call RODE subcommittee, RODE, reclosers and other distribution equipment, if I remember, RODE. They cover all the outside substation standards. And there is a standard on high voltage switch. Not standard, there's a subcommittee, and there's a slew of standard under high voltage switch. There's a special subcommittee for fuses. And it goes like this forever. So again, there's 100-some plus documents. We do not work, and there is total of about, I mean, if you look at the full members of committee, maybe less than 100, maybe 80 members of the switchgear committee, and total membership, with guests including, is sometimes goes up to 150, maybe 200. It depends how many guests show up. And we do not work in all the standards all the time. And I'll show you some other slides in terms of standard cycle, because standards are not cast in concrete either. And I think you made a good point about what version of that standard was in CFR. We say, well, this is 1970 version. Is this the most recent one? Well, we often put the year of the standard at the very end to make sure which version you're talking about. If I have a 1970 version of that standard, well, perhaps there's a newer one that I have to comply with. So I have to look up what the current standard is. The cycle is continuing. Actually, IEEE requires that the standard cycle is 3 to 5 years.
No, they just changed to 10.
Or 10 years. Okay, thank you. Well, it used to be...
No more reaffirmation.
No more... Okay, so it changes a little bit, but if there is a cycle that was required, to go through the standard and at least review if the standard is current, and either reaffirm or modify the standard or develop a new standard or drop it. You say, well, you can withdraw the standard. I say, no, this is no longer valid. The industry changed. We have to do something else. This is just a sample of them, and I don't want to bore you. You cannot even read this small print. But this is a sample of what the switchgear committee does. And again, the C37 series goes from 04 to whatever ad nauseum there. But it goes, as I said, switches, buswork. It goes to switchgear, insulated interrupter switches, service conditions, guide for synthetic testing, and there are even standards. I don't know if I have, there are even some very specific standards. Let's see if I had one here. Oh, that's an interesting one. C3785, for example. There's a standard that requires some safety checks on vacuum interrupters, because vacuum interrupters can potentially under test emit X radiation. So if I work with vacuum interrupters, particularly in the testing part, you better at least be aware of the X-ray limits for these kind of devices. And so some of them are quite detailed. There's a lot of standard on testing and test procedures. Again, how you prove that the equipment is good or complies with whatever requirements. Another acronym, IEEE SA, another way of making money for IEEE, jokingly said. But if you are a member of IEEE, you are not necessarily entitled to participating in standard development process. You have to be also, on top of this, member of IEEE SA. And I forgot exactly how much it cost. You remember it was $35 or $40. It started with 10, I remember when they started it, and $10 on top of your regular annual membership of IEEE and PES. Now it may be $30 or $40. It's like everything else. But you have to be a member of IEEE SA as an individual person to participate in any of these standard processes. Okay. IEEE SA is a consensus-building organization that nurtures, develops, advances global technology, and so on, But the function is to provide the vehicle for individual members to participate in this process. I'm a member of IEEE, I'm a member of PES, and I'm a member of IEEE SA. So my bill from IEEE is some $300 or so, plus maybe now. I haven't checked. Well, I think I paid this year, but next year it's probably going to be more. But you have to be member of at least IEEE and IEEE SA to be involved in the standard process. And I tell you a little bit more about why you should be involved in the standard developing process. So summary so far is that the standard process, both from ANSI point of view as well as IEEE, which is a major part from the power side, is voluntary. It's by consensus. It's an open process. It's balanced process, So when we, for example, ballot, or we have a balloting pool and people start voting on the process, IEEE actually looks at the balance of how many of these in a pool are from the manufacturing side, how many of them are user side, how many of them are consultants and academics and others. I think there's 4 categories altogether. They want to have approximate balance. So, for example, and it happened before where, especially I think in computer society, there were 150 members from one company on a working group, on a balloting pool, and with 3 others, and they say, well, the standard passed. Well, yeah, but there was an interest of this company to pass the standard, but not too many people from outside really participated. So they want to make sure that there's at least approximate balance, between these 3 or I think 4 different categories. And again, there is a right of appeal, not just on ANSI, even in IEEE. And it happened, I was involved I witnessed in the switchgear committee where individual companies or members appeal for the standard, say, I disagree, they did not address my comments, and I still have a negative vote, and please address it. And obviously it goes through a lot of arbitration procedures and so on, but you do have a right to appeal. So in a standard process, and it just gives you a bit of again, very generic kind of thing, they, as I said, are very living documents. They go through the cycles or stages, and they have approved, withdrawn, and reaffirmed the standards. You have to make sure that if you are writing a spec or if you are buying a piece of equipment, if you want to make sure that the equipment is compliant with the newest version of the standard, you have to make sure which version it is or which standard it is. In terms of how we develop the standards, well, we start with writing the standard. And to write the standard, let's say a switchgear committee decides to write a new standard on a DC fuse, per se, high voltage, 5 kV or whatever, DC fuse. We form a working group. It doesn't have to be necessarily from within switchgear committee membership. Anybody, it's a democratic process, anybody can be involved. You have to be aware of this, and to be aware of this, I mean, you look at the IEEE site, and they actually publish in IEEE SA website, they publish all the proposals for all the development of new documents. So you can scroll through this. In fact, if you do your own profile within IEEE SA correctly, they will automatically notify you of all the new projects that are coming up. So if you, in your profile, you say, I'm interested in switchgear, I'm interested in fuses, and I'm interested in transformers, guess what? You're going to get a lot of notification from IEEE. Oh, there's a new C57.142 standard that the people are working on. And then you have a choice. You want to get involved? Sign up. You don't want to get involved? That's fine too. But there is a working group formed, and there is a technical committee that has to sponsor it. It doesn't mean that you have to be a member of this committee, but there's a technical committee, let's say switchgear committee, that has to sponsor this particular work. And the PAR, the project authorization request, has to be approved by IEEE because they check to make sure that we're not encroaching on somebody else. They have to make sure that there's no parallel effort, that they have to make sure that there's no conflict with other organizations. So there is a process on what we call a PAR. Finally, you write. I mean, it takes 1, 2 years, 3 years, sometimes many years, but you develop a document. You finally go for ballot. Another open process where you form, first of all, you form what we call balloting pool. And again, if you're part of the IEEE SA and you have your profile specify what you're interested in, you will get an automatic message, like I do all the time, almost every day. I say, well, this standard's coming up, this standard's coming up, this is within your profile, and then you have a choice. I say, do you want to get involved? I can sign up to be a member of the balloting pool, or I might say, no, I'm not interested in this one, let it go. You know, it's not within my interest. And again, you do not really have to be involved in a working group to be in the balloting pool. Notice there are 2 different groups. There's a working group, people actually developing and writing standards, but then the balloting is another open process, and anybody within IEEE SA membership can participate. I mean, even if it's not your discipline, if you really want to participate in a few standard, but you're in electric machines or in baking or whatever, that's fine. I mean, it is an open process. You have the membership, you bought your dues, you paid the SA $40, you can sign up to be a member of the ballot. Obviously, if you are a baker rather than electric power engineer, somebody at the balloting pool, most likely the chair of the working group, will look at some of the credentials, will say, oh, doesn't look like, he's from American Fence Society or Acoustic Society. I mean, he really doesn't know much about the short circuit current. Then, we might argue about this, but I don't know of any case, myself, from my 17 years of career in IEEE, that we rejected anybody in a balloting pool because of lack of credential or wrong expertise. So almost anybody can be a member of a balloting pool as long as you buy a membership. So this is one group that develops the standard. This group will actually ballot the standard. Typically, this group is 20, maybe from 10 to 30 people, 40 people. This group could be 200 people, 2,000 people. It depends how important the standard is, how much it covers, what kind of impact it has on the industry. So it's a much larger pool. And again, it has to be balanced and open to all the within product democratic process. I mentioned this before. And finally, you go for the ballot. You have to build the consensus. The same as ANSI. The minimum requirement to pass the standard is 75%. You need a minimum of 10 people to ballot. With one, looks suspicious. So there's a minimum number of people. Usually, there's not a problem to meet this requirement. Although I think it happened to me 2 or 3 times that just very few people. I think it was on overhead line somewhere that was a standard that we just didn't have enough people in balloting. We actually had to go through another process to invite more people to participate. But we have to have a 75%. You have to resolve negative ballots with comments. If somebody casts a negative vote, first of all, you have to comment why this is negative. I mean, saying, I don't agree, it doesn't help anybody. Huh? But if I say, I don't agree, and I'm going to write down, or even you can attach your own file with graphics, whatever you want. I say, I don't agree because this short circuit current is calculated for this kind of system condition. And in some other cases, you can see that the different system conditions will respond to different short circuit currents. Then this working group, and it goes back to the working group, these people have to address that. They have to read this, they have to consider, and within 20 or how many people are sitting in the room and say, well, how we address that concern. If it's a valid concern, we have to modify the document. If we feel with a group of 20 people in the working group, it's not a valid concern, then we have to write the response. Mr. So-and-so, and sometimes we don't know who they are, but so-and-so, well, this is not valid concern because, well, no. But at least we addressed it, okay? If we have all these comments, we have to recirculate ballots again to make sure that whoever voted negative hopefully will change their mind and say, yeah, you addressed my concern, or yeah, maybe I was wrong, yeah, you're right, yeah, okay, let it go like this. But it goes back to the consensus building. Very democratic process. So, with all the democracy that I mentioned in IEEE, I want to say a few things about international standards and a little bit of a dual logo. Let's see what time we have. We have 15 minutes left. IEC, and you've seen it, 61850, you've seen many other IEC standards. Some of you are probably using IEC standard in many equipment. Stands for International Electrotechnical Commission. They are based in Zurich, Switzerland, or Geneva, I think. Somewhere in Switzerland. I think it's Zurich in Switzerland, the headquarters. Develops international standards for electronic equipment and related technologies. So from the scope point of view, very similar to what IEEE is doing. Well, IEEE is Institute of Electrical and Electronics Engineer, so we're dealing with the same kind of industries. But they are fundamentally different rules. And one of the main fundamental rules, which was it still is one of the impediments for synchronizing those two worlds, the world ANSI, world IEC, those two halves of the globe. One of the impediments for this is in IEC, you cannot be a member. It's your country that is a member. US has one vote, no matter how big it is. Albania, and I have a good friend in Albania actually, has one vote too. And Portugal, and Poland, and Russia, and China, and Australia, and you name it. Democratic process, it's like UN. It's like UN, but this is what you have. So what you can do is, at best, you have to go through your national committee if there's something in IEC that you like or you don't like or you want to be involved or you want to object. So these national committees actually nominate members to what they call technical committees and subcommittees and the maintenance teams, again, to work on the standards. They have sort of similar structure, and I'll show you a little bit of these technical committees later on, but it's similar, but it's not the same. So one-to-one kind of comparison is not possible, unfortunately. Very similar, and we sort of know where the boundaries differ, but it's not one-to-one relationship. And again, voting on the standards also by countries, one country, one vote. So some of these technical committees, and this is not a complete list again, it's just a snippet of it, but look at the TC17, which is close to my heart, so I always quote that. TC17 is what you would call IEEE switchgear committee, because they call it switchgear in control gear. And within that TC committee, you have subcommittees A, B, C, and D, high voltage, low voltage, assemblies, and so on. Huh? And then you have TC18, 22, and power supplies, power electronics, and so on. So you see similar kind of titles, but again, not one-to-one relationships. So that's a little bit tricky there. You have to see, how, from your point of view, how it matches with the IEC world. Makes our life as vendors, global people like ABB, where we think, or say, we build a breaker that is good for everything, difficult sometimes. I have to admit, it just makes it difficult. It would be so much easier if we could be like in electronics, where this laptop is a laptop, and I don't care if it's in Europe or in the US or in China. In power industry, we are not there yet. Maybe we will. I don't think in my lifetime, at least before I retire, but hopefully at some point we'll get to at least very close. And that's some other subcommittees. I don't want to go through all the details. But funny thing about this, and many people don't remember, that IEC is not IEC. There are so-called in-country clauses. The IEC provides a basic document that all the IEC countries would comply with, but each individual country can also add what they call it informative annex. They say, in China, by the way, we have 40.5 kV instead of 36 kV, and might be slightly different. And in China, we obviously need 36 kV equipment, but we also need a little bit of different clearing time for a circuit breaker. And they are free to do that for the country-specific annex. It is informative annex. It's not part of the standard. It's like a like an annex. I mean, like a note that you put into the standard. But these clauses may become normative in the relevant countries once IEC standard is adopted as a national standard. So there are deviations, and I know a few examples at least that the country-specific clauses maybe not deviate, they do not contradict with the main body of the standard, but they put something on top of this, in addition to the main body of IEC standard. Again, makes life difficult and tricky, not just for manufacturers, for the people specifying equipment as well. Another organization, another acronym, SIGRE, or SIGRE, whatever you pronounce it. I don't know what it stands for exactly in French, because it started in France in 40s or maybe 50s, something like this. But in English, it stands for International Council on Large Electrical Systems. SIGRE to IEC, it is what IEEE technical committees are to IEEE standard writing committees. They provide technical expertise or technical consultation to IEC about technical subjects that are basis of writing a standard. A standard says, you need this and this, you need this and this, and you have to test it like this and this. SIGRE justifies on a technical side why this might be or is important, or why this should be in the standard. I'm actually involved in SIGR as well as between SIGR and IEEE there is an agreement, global agreement for cooperation, and I'm one of the liaisons between IEEE and SIGR, again for switchgear committee. But this is a technical arm of IEC. And it has their own study committees, and there's 16 of them. And one of them is that I sit in, which is study committee A3, high voltage equipment. And again, unfortunately, it's not exactly one-to-one comparison with what IEEE does, because this thing, with the in addition to the switchgear that you know from IEEE, for example, covers high voltage capacitors, which we don't. It's in a capacitor subcommittee in our case, in IEEE. This covers instrument transformers, which in our case, it's in transformer committee. So it is 80% compatible, but not 100%. So it makes life difficult for everybody, but that's what it is. And finally, dual logo, and I mentioned a little bit to one of you gentlemen before I started. IEEE and IEC, some few years ago, finally sat down together and say, guys, why are we doing this to each other? I mean, could you at least harmonize? Maybe it's not going to be identical, but could we at least get close or get some agreement so we don't have to redevelop the wheel every time? I mean, basically, it's a redundancy, it's a parallel path. So they actually agreed on what we call dual logo, and there's obviously the legal language in this, but they negotiated the deal to coordinate and cooperate in standards development process. And I tell you a little bit more about this. First, it was aimed at identifying IEEE standards and draft standards as candidates for processing through IEC full consensus procedure. And then it has been expanded to include the joint development for new and existing standards. So at the beginning, we sat down together and say, you guys in IEEE have standards that we don't cover at all. We don't have any equivalent in IEC. And the example I was giving before was the generator circuit breaker standard, which in IEEE has 15 years of history on the C37013. And I say, all right, this 13 covers this generator circuit breaker, very specific kind of application. IEC doesn't have anything. So I say, well, could you just adopt this in IEC standard, as long as you go through the IEC full consensus procedure. Remember, the procedure is by country, not by membership, so you have to go through that separate country process, all the IEC stuff, you have to follow the procedure there. But as long as you go through this, then I say, oh, we can make this an IEC standard as well. So one develops it, the other one adopts it, and we have. And now on the second part, they say, from the beginning, if we think of something good, could we jointly start a working group? Let's call it IEEE/IEC working group, and again follow parallel process, but develop a standard that at the end will be both IEEE and IEC. That's why we call it a dual logo. And indeed, I think there are two documents. I know that the recloser document, C37.60, is now a dual logo document, which is both IEC and ANSI standard, and generator circuit breaker is another one. And I thought there was a third one. Maybe I draw a blank here. But there's at least two precedences in switchgear committee where this thing actually worked. Very painful process. And believe me, I know the chairman of this, and this guy suffered a lot because he traveled between different countries, and he tried to get the consensus within IEEE membership, and he got this, but he had some negative votes in countries, and he had to address this. And when he addressed it, he went back to the IEEE balloting pool, and then some people didn't agree there, and back and forth. So it was an almost impossible task, but he did it. Actually, at the end, people are, they say, why not? I mean, it's, and sometimes actually the same people sitting in both committees. So it's sort of funny way how the same person, being an individual member of IEEE, can also be part of the national committee of IEC. But it happened. And there is some progress. And I'm glad to report that these two organizations finally started harmonizing standards. And I think the first one is this first standardization committee started in 1898, and AIEE started with the standard 19. But I want to show you this picture. I always like that one. 1901, I don't know if you ever work with switchgear, but this is a circuit breaker. There are two barrels full of, pickle barrels almost, full of oil, and there is a cross arm there, and then little pull rod, if you will, for actually withdrawing these contacts under oil, and you have a cable coming in and cable going out, and this is how you interrupt the circuit in 1901. And this is a real installation. I mean, this is actually in the field. And this particular one, note here in the caption, was good for 40 kV. You say, wow, great, huh? 40 kV, 2 barrels full of oil. I mean, each one is, 75 gallons of oil? Good stuff, huh? Obviously, if it didn't interrupt, you have a bit of a problem, eh? I mean, that's 150 gallons of oil burning. It will take 2 or 3 hours. I mean, these are some of the slides. 1919, there was a club formed in electric power, and in that club, they decided that the breaker must be able to make 2 open operations with 2 minutes intervals. No limit on flame or oil rejected. Doesn't matter. I mean, it can burn as long as it interrupts twice. Beautiful. I love it. Just interrupt. I mean, this is how far we went with the technology. It's amazing. Now we have 100 short circuit interruptions and people complain it's not enough. Electric Power Club merged with Associated Manufacturers of Electrical Supplies, which became NEMA some years later. I think it's the first standard, at least in circuit breakers, was in 1945 or 41, somewhere wartime kind of thing, Second World War, on alternating current power circuit breakers. And again, that was American Standard Association, which was sort of a predecessor of ANSI, what became. And the ASA standard C37, you remember the C37 acronyms, which we still keep today. It's historical for the reasons that they started then. The C letter standard for electrical, and the 37 was for switchgear. It's no longer really valid that much. In fact, 37, if you're familiar, it's also used for protective relaying. It's also a protection device, but it's not the circuit breaker. It doesn't interrupt any current. It's a logic device. It's an electronic device. But it also falls under C37. So it's sort of historical reason. And some of the first standards that were issued, the rated control voltage C37A doesn't exist anymore. A schedule of preferred rating, now it becomes C3706, which NEMA used to handle. Now it's actually part of IEEE because NEMA didn't want to maintain it. But this is just historical, sort of 1940s kind of thing. And the rest is history. Thank you very much. Enjoy the rest of the day.